Hello, ladies and gentlemen. Today we are going to continue on our understanding of lines and take a little time to review slope as well as how to graph a line. So for this, you're going to need your notes, a calculator, and of course, something to write with. So our learning targets today are that we can continue to use our understanding to find slopes of lines. We can use slopes to determine if lines are parallel, perpendicular, or neither, and that we can graph a line. All of these things are things you've talked about in classes prior to this one, but again, review is always nice, okay? So as we take some notes today, you're going to see some things that you need to write down, and then you're going to see some things that are optional to write down that will just kind of develop or review those basic ideas, okay? So let's go ahead here and continue on. Our first idea is the slope of a line. You need to make sure that you have this part written in your notes. So the slope of a line is the steepness of a line as it rises or it falls. It's how steep a line is. Does it go up gradually or does it go up really, really fast? It is a rate of change. You'll hear that a lot in science classes. How did this change over time? And then we always talk about it in math classes as rise over run. Or you'll use the formula y2 minus y1 over x2 minus x1. All of these are ways to talk about the slope of a line. Please make sure that you have all three of these into your notes, especially that slope formula there, as it's going to help us quite a bit as we do some examples. So slopes can be positive, they can work out to be negative, they can even become zero, or what we call undefined. So we'll take a look at a few different examples. This is a little diagram that I'd like you to get in your notes. These are 4 different things that can happen with your slopes of lines. So let me make sure my pen's on here. There we go. This first one here, A, this line is climbing. We always start on the left-hand side of a line, and I'm noticing that the line is going up. That means that this will be a positive slope. So maybe when I solved it, it was like 3/8 or something. It was a positive value. Now the second one here is a negative slope. It starts high here and goes down. That is a picture of what a negative slope will look like. That means when we calculate the slope, we will likely get a negative value, a negative fraction. C right here is an example of zero slope. There's no slope at all, zero. It's very boring, okay? It's that horizontal line. It does not have any steepness to it. Whereas D is really, really, really super steep. It's kind of like a cliff if you were to use the mountain analogy or skiing. This is the undefined slope. So the difference between zero and undefined, one's horizontal and one's vertical. A zero slope might have a fraction of 0/8 or 0/7. All of these equal a zero slope, whereas an undefined slope may be something like it went up 3/0. The fact that there's a 0 in the denominator, this is bad, can't have 0 in the bottom. And that's what makes him undefined. So as we look at doing some slope examples, think about these little pictures to help us make sense of those slope answers that we're getting. Okay, so now let's look a little bit further at understanding different types of lines. Parallel lines, perpendicular lines. Parallel lines from geometry are lines that are in the same plane and they never intersect each other. And perpendicular lines are lines that intersect to make 90 degrees. These two relationships can be shown on graphs, and it looks a little like this. Don't put these in your notes, just watch. Parallel lines are those lines that never intersect, right? If we were to find the slopes of these two lines, like if I pick a point here and pick a point here, and I do rise over run, rise up 2, run over 1, 2 over 1 for this line. Now if I look at this other line, maybe pick 2 different points here, up 2 over 1, notice that those two lines have the same slope. Both of them equal 2. Parallel lines will have that same slope every time. That's what makes them not ever cross. But perpendicular lines intersect, but they do more than just intersect. They intersect to make 90 degrees. So that requires a special slope relationship as well. So if I were to find the slope of these two lines, let me just do this one with a couple points. This one is rise over run, so I went down 1, that's -1, over to the right 2. So this one has a slope of down 1 to the right 2. Now let's look at your other line here. I'm going to pick up a couple points, nice points here, and I'm going to calculate his slope or do the rise over run. Up 2 over 1. He has a slope of positive 2 over 1. These two lines intersect to make 90 degrees. They do that because their slopes have a special relationship. Notice these two slope values down here. One is positive, one is negative. And also they are reciprocals of each other. That's huge. These two relationships are something that you looked at in geometry, you also looked at in Algebra 1. Make sure that you get this part in your notes. If two lines are parallel, then the slopes are in fact equal to each other or the same. If two lines are perpendicular, then the slopes are opposite. That means one's positive and one's negative, and also reciprocal. So they are opposite reciprocals of each other, like 1/2 and, 1/2 and -2 over 1. That is an opposite and reciprocal relationship. You flip one over and you make one negative. That's the idea of opposite and reciprocal. So now let's take a look at an example we should get in your notes. Are these lines parallel, perpendicular, or neither? So we're going to use our slope formula, and we're going to apply this idea of same slope or opposite reciprocal slope. So here we go, line number 1 first. Line number 1 goes through these 2 points. Now each point has an x and a y. This is an x, this is a y. This is an x, this is a y. And because these points are listed in a certain order here, I might call this one x1, y1. X in the first point, y from the first point. X from the second point, y from the second point. And so my slope formula is y2 minus y1 over x2 minus x1. So if I use that setup here, let's go ahead and set that up. Y from the second point is labeled as 2 minus y from the first point is labeled 0. Now x from the second point is -1 minus x from the first point is 3. And so if we calculate this, we get 2, -1 minus 3 is -4. So I get a slope of -1/2 if I reduce that. And you always want to make sure you reduce them so that you can see that relationship, so that you can see if they're really equal or if they're opposite reciprocal. Okay, now let's look at line number 2. Same idea, 2 points, x1, y1, x2, y2. I'm just going to label those so that it makes plugging into that formula a little bit easier. And now we'll follow the formula y2, y from the second point, minus y from the first point, x from the second point, minus x from the first point. And we'll go ahead and calculate those two values. 4 minus 0 is 4. 3 minus 1 is 2. And if I reduce that, 4 divided by 2 is 2 over 1, or just 2. So this is the slope of the second line. This is the slope of the first line. Now notice the relationship there. That is an opposite and reciprocal relationship. That is telling me that these two lines are perpendicular. Or if you like the little symbol from geometry, that's that upside down T like this. But they are perpendicular lines, and I can tell not because I graphed them and got out a protractor, but because I know the relationship that the slopes have. Okay, so that's how we'll be using our slope formula in understanding relationships between lines. Let's take a look at that whole graphing piece. That was another one of our learning targets. So please make sure that you get this part in your notes. A linear equation is an equation that uses x and y and graphs into a straight line. So these are 3 examples of linear equations. Notice that they have x and y. It's not an x squared or a y squared. Each of them have an x and a y. They're all a little bit different. Now, solutions to linear equations are a little bit different than solutions to a standard equation where you're just solving for x. A solution to a linear equation is a point. So it's an x and a y that works in the equation to make it true. So here's an example here. Is the point 5, 4 a solution to the equation y equals 2x minus 6? How would I know? Well, I'd test it out. There's a 5, 4. 5 is the x, 4 is the y, and if I plug it into this equation down here, it has to work to make it true. So this was the x, and 4 is the y. We'll go ahead and plug it into the equation and see if it works. So 4 equals 2 times 5 minus 6. So I'm going to leave the 4 on that side. 2 times 5 is 10 minus 6. Is this look like it's true? Yeah. 10 minus 6 is 4. 4 equals 4. Yes, it works. So yes, that point is a solution to that equation. But is that the only solution to that equation? Are there other points that would work? Well, that leads us to what a graph represents. Don't write this part in your notes, but when we make a picture of a graph, guys, of an equation, we collect all the points that work, all the points whose coordinates are solutions. The x values are the domain, the y values are the range again. Remember all those key words. So that means when I have a graph and I have an equation that I'm trying to graph, I might find one good point like this, but there are other points that work too, like this one, and this one, and this one. And when I graph all the possible points in the world, guys, that's what makes that line that we see when we graph a line. So write this part in your notes. One of the ways that you graph that line was using slope-intercept form. This is one of the faster ways to graph a line. This is one that you probably spent a lot of time with in Algebra 1. But understanding that a linear equation in y equals mx plus b form is said to be written in slope-intercept form. That means that m tells you the slope and the b part of the equation tells you the y-intercept. So the m is the slope and the b is the y-intercept. And using those two pieces of information, you can sketch a graph of the line. And a line is a picture of all the points that work in an equation. So let's graph this little guy right here. This will be our last example we get in our notes. We're going to graph this line using y equals mx plus b form. So when you want to use this quick way to graph, notice what has to happen. The y has to be by himself. In our example here, the y is not by himself. He's got an x over here, he's got a 2 in front, so we have some work to do. We first need to move away the x's so that the y can be alone. So I'm going to subtract 3x from both sides. They will cancel on this side, and I will have 2 y's. And on the other side, you'd have 4 subtract 3x. Well, you can't subtract x's from a regular number 4, so we just leave it as negative 3x and a positive 4. I usually write the x's in front of my standard constant numbers because that's standard form, and also because I want the m, or the slope, to be at the beginning. So I'm going to now divide by 2 to get my y alone. Now that means you divide every piece by 2. So y equals, can you divide negative 3 by 2? You could if you wanted to write a decimal, but I would suggest you don't, because remember, this fraction is in front of the x, or with the x. That represents our slope, and we like slope as a fraction. It's a rise over a run. Now 4 divided by 2 is nice, that's just a 2. And so when we look at this now with the y by himself, 2 is the y-intercept. So that's going to be a dot that you place on the y-axis, and this is the slope. So now he's in y equals mx plus b form. Now sometimes people don't know which thing they put on the graph first. The b is the thing that goes on the graph first. B for beginning, okay? Begin here. We're going to do the y-intercept of 2 first. So on my graph it'd be right here. And then from there we're going to move, m for move or slope, we're going to move the slope down 3 over 2 because the slope is negative 3/2. So we go down 3, 1, 2, 3 over 2. Always go over to the right, positive 2 there. And my next dot would go right here. I went down 3 over 2. And then when I connect those two dots, all you need are those two dots. If you want to draw more points, you can. You connect them with a straight line, and you always put arrows on either end because, again, it's a line and it goes on and on forever. These are just 2 points of many that would work in that equation, but we're trying to draw a picture of all the points that work. Okay, so hopefully that was a little review on how to graph a line. Getting that y by itself is a big idea, and also knowing where you start when you plot these points. We're going to continue more practice on graphing and understanding all things linear in days to come. Thank you for taking good notes.